Namaskaram students. In the previous video we learned three important metallurgical processes. They are concentration of ore, extraction of crude metal, third one is refining of crude metal. Now in this video we are going to learn thermodynamic principle of metallurgy, electrochemical principle of metallurgy and Hall-Héroult process to extract aluminium metal. Now, thermodynamic principle of metallurgy. What is thermodynamics? Thermo means heat, dynamics means moving. With the help of heat moving, that means heat giving, the metal oxide becomes metal and oxygen with the help of reducing agent. What reducing agent we are going to use here? The carbon or carbon monoxide. So, this thermodynamic principle give the condition, a suitable condition for that reduction reaction. With the help of the condition, we choose whether that carbon or carbon monoxide for this metal oxide. So, what is the condition here means? We have already learned in our 11th standard, for spontaneous reaction, the change in free energy, delta G value should be negative. So, this is the suitable condition for that metal oxide. For that, I written here 4 reaction. First reaction, metal oxide. They given us metal has a M and O is a oxygen. That oxidation state of oxygen is given as X and oxidation state of metal is Y. So crisscross method you applied here means we get MXOY. In the reactant side, first of all you don't see 2 by Y. Y means it is for balancing purpose they given us 2 by Y. Now you see the product side, there is M plus O2. What is M here? Metal, and then oxygen is removed here. So that oxygen is given as O2. For balancing purpose, first of all, O2 means how many oxygen is there? 2 oxygen in product side. So that to balance that one, we put 2 here in the reactant side, and Y is, now Y is in the substitution to cancel the oxygen in the reactant side, so that we put the Y as a in the substitution of 2. The same way in the product side, now we balance the oxygen, but in metal side, how many metal is given in the reactant? X metal is given, so that we put in front of the M X and in front of the M we put 2, because in reactant side we written 2. And also to balance in the reactant side the substitution Y by Y also in the product side in front of the metal. In the second reaction, first of all the carbon reacted with oxygen gives carbon dioxide, and again that carbon reacted with oxygen gives carbon monoxide. Carbon monoxide once again reacted with oxygen gives carbon dioxide. So these are the 4 reactions. Here combination of 1 and 2 or combination of 1 and 3 or combination of 1 and 4. Which combination give the delta G value negative? That is the suitable reducing agent for that metal oxide. The next principle is electrochemical principle of metallurgy. Here why we are using electrochemical principle means for some metal oxide, for example sodium oxide or potassium oxide, the reduction with the help of carbon by using the heat alone it is not possible. That is, it is given as feasible. Feasible means what means? It is not possible with, by thermodynamics. That means heating alone it never reduced. For that purpose only we are going to here using electrochemical method. First of all, what metal oxide you are going to use? That metal oxide we have to change is a fused state or solution form. Fused means it is a melted form, and solution means with the help of solvent we are going to change that metal oxide as a metal ion in the solution form. The metal now the metal is metal ion in the solution form, that is reduced to metal by treating. The first one is suitable reducing agent, the second one by using electrolysis. We are going to see now first one. For example, copper is more reactive than silver. So you are going to give the copper as a metal and silver as a ion. See the first equation, copper plus Ag plus. Copper Cu means metal, Ag plus means ion. Now see the product side. Now copper is become as a ion and Ag plus is become as a metal. What we are going to say here means copper is more reactive metal. That more reactive metal change the less reactive metal as a metal. Metal ion is changed as a metal. See the now second reaction, when compared to zinc and copper, copper is a less reactive one and zinc is a more reactive one. Now the zinc reacted with the copper 2 plus. Now change that copper 2 plus as a copper metal and zinc is changed as a zinc 2 plus ion. So here the reactivity of silver, copper, zinc is more reactant than copper, copper is more reactant than silver. So by using this method we can reduce the metal ion into metal. The second one by electrolysis, the second one for the electrolysis, the formula is given as delta G degree is equal to minus N of E degree. What is N means number of electron. What is F means Faraday and E degree means standard EMF. This equation you will learn in the electrochemistry in next value, second value. If E degree is positive, see the equation. In the equation it is given as negative 1. What we have already told for our spontaneous reaction, delta G value should be negative 1. So we get the negative by applying E degree value as a positive one. So for the electrolysis process, we have to plan to produce the degree value, E degree value, that means standard EMF value is positive. Our next process is electrochemical extraction of aluminum. The process name is Hall-Hérold process. In this process, we are going to take cathode which is act as a cathode. Here means the iron tank lined with the carbon is act as a cathode, and we are going to hang some carbon blocks. That carbon blocks is act as a anode. Now we need a electrolyte. That electrolyte means the liquid part between the cathode and anode is called as electrolyte. Here electrolyte is 20% alumina. Alumina means Al2O3 and it is added with the molten cryolite. The cryolite formula is Na3Al F6 and one more thing we are going to add as electrolyte, that is 10% calcium chloride. Here what temperature we are going to maintain means above 1270 Kelvin. The next one, here electrolyte we used here calcium chloride along with the alumina and cryolite. The function of calcium chloride is lower the melting point of mixture. Now we are going to see the reaction. First of all, on passing electricity, the first of all that alumina means what? Al2O3. Now it is changed as a ions. That means aluminum is become as Al3 plus and oxygen is become as O2 minus. In the second equation, first of all see the reactant side. How many aluminum is there? 2 aluminum. For that purpose only we are going to write 2 in front of the product. Al3 plus 2 you are going to write. The same way in reactant side, how many oxygen is there? 3 oxygen. So you write 3 before the O2 minus. Now see that in aluminum 3 plus, what is the character of aluminum here? Positive character. Always the positive character goes to negative character. That means it reaches the cathode. Cathode has the character of negative. The same way oxygen 2 minus, it has the character negative. So it goes to positive. Which one has the positive character? Anode has positive character. So oxygen 2 minus goes to anode. At the cathode, what type of reaction take place? Reduction. How can you remember this reduction take place in cathode? By the using the CAR word, remembering the CAR. What is CAR here? CA means cathode, R means reduction. Reduction means you have to remember the word register number. In register number, what is the R? R is the reduction, E is the electron and G is the gain. So in reduction means the gaining of electron. Now see, refer the equation 2. How many aluminum 3 plus there? 2 aluminum 3 plus. First of all, you see the first one aluminum 3 plus. In one aluminum 3 plus means it has excess 3 proton. So to compensate 3 proton by 3 electron, so that now we get aluminum metal in third equation. But if we refer the second equation, how many aluminum 3 plus we are getting? 2 aluminum 3 plus. For that purpose, you are multiply the third equation with 2, we get 2 aluminum 3 plus plus 6 electron, and we get 2 aluminum atom. Now anode. What type of reaction take place here? Oxidation. Oxidation means loss of electron. So first of all, oxygen 2 minus. Above the oxygen, how many electron is there? How many minus is there? 2 minus. That means 2 electron is there. Excess 2 electron is there. That excess 2 electron is going to loss in the anode. So that we are getting in fifth equation, O2 minus becomes O plus 2 electron. Now never that oxygen becomes a atom alone. It becomes a molecule only. How can you write that molecule, oxygen molecule O2? So see the equation 6th one, there is O2 in the product side. So product side 2 electron, 2 oxygen means in reactant also you have to write 2. So for the purpose, in front of O2 minus I wrote 2, and you multiply the 2 with the equation 5, you get electron. How many electron you get? 4 electron. 2 into 2, 4 electron. Now you refer the second equation, how many oxygen 2 minus is obtained. On referring second equation, how many oxygen 2 minus you get? 3 oxygen 2 minus you get. So that purpose only we are going to multiply the sixth equation with the 3. So that we are getting 6 O2 minus and 3 oxygen O2 and plus 12 electron. This is equation 7. Now equation, refer the equation 4. The equation 4, how many electron is there? 6 electron. But in 7th equation, how many electron is there? 12 electrons. So to compensate these two, we multiply the fourth equation with 2. So that the fourth equation now becomes as 4 aluminum 3 plus and 12 electrons and 4 aluminum. Now for anode, we are taken as carbon. That carbon also the following reaction will take place. See the ninth equation, carbon plus O2 minus gives carbon monoxide. That means carbon reacted with oxygen gives carbon monoxide. In the second equation, that means the equation, the carbon monoxide again reacted with oxygen gives carbon dioxide. Now see the 11th equation, carbon reacted with oxygen directly give the carbon dioxide. What is the difference between 9, 10, 11 means? First of all, carbon reacted with oxygen, carbon monoxide. Carbon monoxide with oxygen gives carbon dioxide. Now the carbon directly reacted with oxygen gives carbon dioxide. Now see the ninth equation. In oxygen, how many minus 2? 2 minus. For that purpose, it going to lose the electron. The 2 electron is written as a product side. Now see the 10th equation. In the 10th equation, it is also having 2 minus, oxygen 2 minus in the reactant side. That 2 electron is going to loss. Now we get CO2. In 11th equation, we get the product side carbon dioxide. So for that purpose, we are going to write 2 here. Now multiply equation 11 with 2 to balance the electron. So now take the refer the equation 11. Now we get 2 carbon along with that 4 oxygen 2 minus, so that we get 2 moles of carbon dioxide and 8 electron. The next one, we are going to add equation 8, 9, 10, 12. So that I written one more time the equation 8, 9, 10, 12. Now refer this equation. In product side, how many aluminum is there? 4 aluminum. In reactant side, how many aluminum is aluminum 3 plus there? 4. So now write 4 aluminum 3 plus down and 4 aluminum product side down. Now see how many carbon is there in reactant side. 1 carbon in 9th equation and 12th equation 2 carbon. So add these two, we get 3 carbon. So first of all write 3 carbon in the reactant side. The next one, in oxygen 2 minus, see the equation 9, 10, 12. How many oxygen? Totally 6 oxygen 2 minus we are getting. Now see the product side, 4 aluminum we get, so that we are written 4 aluminum, and carbon monoxide. See the carbon monoxide in the 9th equation, it is written as in reactants product side. Now in 10th equation it is written as in reactant side, both are cancelled. The next one, in product side, how many carbon dioxide in 10th equation? 1 mole carbon dioxide. In 12th equation, 2 moles carbon dioxide. Now add these two, we get 3 moles of carbon dioxide. Now see the electron in 8th equation. How many electron in the reactant side? 12 electron. In 9th, 10th, 12th, now add the electron in the product side, we get 12 electron in the product side. So now we are going to cancel these 12 electron reactant side and product side, so that we are getting the equation 13. What we are going to say here means the aluminum 3 plus, the 3 plus is in the form of compound. That compound now not compound here, it is a oxide Al2O3. Now it is reduced as a aluminum with the help of electrochemical method. What is the name of this process? Hall-Héroult process. Now because of the equation 9, 10, 11, 12, refer that equation. Here we are using only carbon, so that the anode carbon slowly used by that electrolysis process. So we have to replace this carbon anode after using fully. Next, we are getting pure aluminum, that is settled at the cathode. What is cathode here? That ion tank acts as a cathode. So that ion tank at the bottom, we are getting pure aluminum.